Art takes on many forms, and one of them is string art. It looks a lot different from the typical art you create with pen and paper. Instead of drawing on a canvas with a brush, you work with a circular board with n amounts of pins on the side, around which you put some string and connect the string from one pin to another until the string resembles the original image. And so in this video, I will create an algorithm that takes an image and turns it into string art. So how does it work? As my first step, I want to turn this image into grayscale, because that makes the algorithm a lot easier. To handle this part, I use the library. Once you have your grayscale image, you need to save it as a two-dimensional array, which stores the grayscale value of each pixel. You could either have it be like 0 as white and 255 as black, or how I did it, 255 as white and 0 as black, like in RGB values, where 255 is white. Depending on your choice, you'll need to make some adjustments later, like adding when you subtract and vice versa. And if your image doesn't have a 1:1 ratio, you have to crop it as well. The next thing you need is an amount of pins around the center point in form of circle. You select a random pin as the starting point. Now comes the important part. The simplest way to proceed, and the way I did it, is to select a set of pins, excluding the starting one. I just selected all of them. It takes more time, but the result will likely be better. You check which line connecting these pins has the darkest average pixel brightness, and then draw a line from the starting pin to the new one. Then you save the new pin as the starting pin and repeat this process as many times as you like. The more you iterate, the darker and more detailed the output image will become. I just used Brazenham's line algorithm to draw the line, although it would probably be better to use anti-alias lines like Xiaolin Wu's line algorithm. Here's the algorithm. If you don't know how this algorithm works, this video explains it a lot better than I could. Link in the description. If you check the line brightness, you can just, instead of adding the pixel to the output, add the absolute grayscale values of all the pixels in the line together, subtract it by removing value, to which I will come in a second, times the amount of pixels, and then divide it by the total amount of pixels. The resulting value needs to get compared to all the other possible line values, and the darkest line gets drawn. Something important in the draw function that you should not forget is that you have to add the values of all the pixels in the line by removing value, because otherwise it will draw the line on the same spot constantly. Now you have those three values: the amount of pins, the remove value, and the amount of loops. I have 360 pins, but you could do more or less, and for the next image, you will see in a second, I used 50 as the remove value and 3500 loops. In the end, the image just needs to be saved somewhere, as for example a PNG file. If I run this code, it will loop through this algorithm and create this string art. Here's a visual representation of what's happening. So obviously, this is the simplest solution, but there are ways to improve the output image. You can introduce an importance variable similar to your image array, but scaled between 0 and 1. This variable is then multiplied with your other pixel data, giving priority to darker pixels, which enhances accuracy in shadow areas, but might reduce detail in brighter regions. Another thing you can add is a value between 0 and 1, which gets multiplied by the removing value to reduce the penalty for negative pixel values. That means that the algorithm is more likely to draw more lines than too few. If you want to add color, you have to run all RGB values individually, probably with slight changes to the algorithm. Note that I did not try those improvements yet, so there's likely to be an error. Anyways, I hope you enjoyed this video. Thanks for watching, and goodbye.